Here's problem 3313. An RLC circuit has R equal to 100 ohms, C equal to 25 microfarads, and L equal to 0.16 henries. For what angular frequency of an AC voltage is the current flow maximum? Now we know in general, whether it be RMS current or maximum current, let's use RMS current, that the RMS current will be equal to our RMS voltage divided by the impedance. So if we can reduce the impedance, we will get our maximum possible current. Now in general, the impedance is going to be equal to the resistance squared plus the net reactance, which is the inductive reactance minus the capacitive reactance squared, all that, square root. One way I can reduce the impedance in order to get maximum current is if somehow I can get this second term here of reactance to equal 0. And hence, in that case, my impedance would just simply be equal to the resistance of the circuit. And there would be no extra impedance due to the reactance, the net reactance. So for that to happen, to get maximum current, I would want my inductive reactance to equal my capacitive reactance. In other words, omega times L should equal 1 over omega times C. Solving this for omega, we would have omega squared is equal to 1 over LC, or omega is equal to 1 over the square root of L times C. That will be the frequency that gives me a maximum value for the current. It'll give me a minimum impedance, maximum current. So in this case, this is going to be 1 over L, which is 0.16 henries, times C, which is 25 microfarads, all that, square root. So if I do that, 0.16 times 25 microfarads, alright, square root, inverse, I get 500 radians per second. So the angular frequency that will give us our maximum current is 500 radians per second, and that corresponds to the impedance equal just to the resistance of the circuit.